So, welcome to lecture 3.3. We are delving deep today into more of our correctness topic, right? And our correctness topic was based really heavily on the idea of how do we make software safe, how do we make sure it works. And specifically today, we're going to delve deeper into static verification. That was something we glossed over a lot in the last lecture. This is the only completely new lecture in the course this term. So this is the first time this 1531 lecture has ever been done. So it's the most likely one for me not to like it because I haven't had a chance to screw it up. Whereas a lot of the other lectures we've screwed up, but let's see how we go. Should be a bit of a fun topic. Before I dig into this though, what I want to stress, and this is really, really, really important, everything from today, so that's 3.3, 3.4, all of week 4, all of this has nothing to do with iteration 1. Nothing. I'm going to say that again. 3.3 onwards has nothing to do with iteration 1. When someone sees someone ask this on the forum, it's up to you to answer that question and link to this video. And this is good. It's designed this way to make your life more relaxing. So it's like we try and introduce topics really slowly this term. It's something I'm really excited about to bring to you all. But also it's important because I know how easily you can get confused because nearly all of you probably haven't started iteration 1. So if I start talking about this today, you're going to think it's relevant, but it's not. We're just introducing it early so you have time to mull over it. So you don't have to worry about this in the labs until next week, right? And you don't have to worry about it in the project until week 5. And for those people who've joined us live today and are asking about if you missed lectures 3.1 and 3.2, yeah, it was on last night. We had a bunch of people come. There'd be there's probably somewhere between 10 and 15 people in the call, I'd guess, who didn't watch yesterday's lecture. It was in the notice. We said we weren't going to move the Monday lecture because it's just too annoying to move lectures because it confuses people, and it's all pre-recorded, so we just kept it at the same time. And to the question that was asked, do I need to have watched 3.1 and 3.2 to understand this lecture? Not really. There's a I'd say it will help 5%. You'll be fine. But if you're really quite, serious, you can always pause it and go back. So let's get stuck into it. So static verification. Why we're talking about this today. Static verification, if you remember, back from, lecture 2.4, 2.3, was about how we improve software safety or improve safety. That's an issue already. It's how we improve software safety before the code runs. So I mentioned this last lecture. The best kind of safety software can have is if you know it's perfect before it ever runs. So it just if it compiles, it works. You never have to write any jest tests or anything. These 3 things are also wrong here. There you go. 2 typos on 1 page. I forgot to update these. My apologies. Let's get into it though. Oh my god, is this the right lecture? It is. Okay. Back when we did 2.1, I mentioned that we had an environment change. This is also true here for this lecture. So in your project for the term, when we release iteration 1, as well as the labs in lab 3 onwards, we started going to a new kind of way of coding, which was to use NPM, right? This lecture today, though, we're kind of going to the next set of topics, which is to use a few other tools, which is type checking and linting. What I mean by that is if you go and have a look at all the lecture code, you'll notice that everything from this lecture to the end of the course is in the env2 folder. So it's kind of like all the code we do from today onwards can't be run with essentially like your previous labs and whatnot. Again, you don't have to do anything. I know I stress that a lot, but I mean it. You don't have to go and change anything. This is all just explaining where if you write some code in lab 4, which has static verification in it, and then you could try and copy and paste that code to lab 3, you're going to have to copy and paste a lot more than your code, right? So don't worry about it. If you don't know what I'm talking about, that's great. It means you're not going to overthink it and you're totally fine. So let's dig into it. Sometimes we write a really nice function like this. Many string. We've seen this before. It's a function that simply goes and takes in a number of times to repeat. It takes in a string. We create a new string that's empty. We loop through the number of times we want to repeat, and every time we loop through, we slap strings together, and then we produce a new string. And you'll see that, you know, we can call it like this, and it should work, right? Many string, we give it the string, we give it the number of times to repeat, and then it should run. Does someone want to tell me what is wrong with this? What do you see wrong with this picture? Someone should know. I got to wait 10 seconds for YouTube and the comments to catch up, but, you know, give you all a minute. Nick, no input check. What does that mean, Nick? What do you mean by no input check? I think you're right, but I need to hear just a little bit more to know that you know what I mean. Okay, so Ennis says the parameters are the other way around. Yeah, so, and I'm sure a bunch of other people will answer as you catch up. So yes, the parameters are the wrong way around. Many string takes in a repeat, then a string, or a number, then a string. But here, we've given it a string, then a number. Now this is definitely going to be problematic because if I go and open up, let's go open up our editor, and let's go and have a look at some code, right? So I'm going to go into my env2 folder here. I'm going to go look at 3.3 many string root here. Sorry, yep, let me resize this. And then I'm going to go run this, and let's see what happens, right? So I go node source / 3.3 many string, oops. Let's go inside env2. Node source 3.3 many string root empty. See, now this is the problem. We don't talk about this a ton in the course, but the best thing a program can do is fail to compile. That's the best thing it can do. The second best thing it can do is crash when something goes wrong, and the worst thing it can do is succeed thinking it worked, but it didn't. And this is that third case. This is the worst case. The program did not fail. And what do I mean by fail? Well, JavaScript's a little bit different, but if I say something like, you know, const a equals 3 divided by 0, this program will, well, this program is happy. JavaScript's a bit of a dirty language sometimes. This, I think, just turns it into nan, which I don't like very much. It's not infinity. Okay, let's not get started there. But, you know, the worst thing a program can do is succeed here, because what happened is repeat is a string. And what happens here? What happens when I do I less than a string? Let's try it out. So if I is 0, let's open up the interpreter. Let's try it out. What is I is less than hello? Uncaught ref. Okay. Const I equals, sorry. What is 0 is less than hello? False. Right, so it's false. So immediately it just never goes into the loop. Okay, so it never loops. So because of the way JavaScript works, when it tries to check if 0 is less than hello, I don't quite know why that's false, but it probably tries to convert, I actually don't know how this works. Like, I'm not sure if it tries to convert 0 to a string, and then it tries to compare two strings. Like, what if you say is A less than B? That's true. Is 0 less than H? That's true. So I don't really get... So I don't think it's converting it to a string. I have no idea. You can go look this stuff up online, right? I don't keep it on the top of my head. You should not be expected to. It doesn't really matter. But the point is it's breaking. And we knew it was breaking before it ran. It did not have to run, right? So people might be like, oh, we should put in some checks here. Like, and this is what we're about to get to in the slides. So you're going to put in some checks. Okay? The problem prints nothing. It's the worst mistake. How can we protect against this? We start adding checks in. People said this before. JavaScript has this great... I don't know if it's a function. I guess it's a function. It's a bit of a weird keyword. It's the instance of keyword. I don't know what you call these things. Google will tell me. Right? Instance of operator. Okay, it's an operator. And basically, what happens is if you take repeat, which is a variable, and you say instance of and then number here in the quotations, this will return true if repeat is a number. Oops, I'm on the wrong screen. So if repeat is a number, it will return true. Now, what are the different instance of types? There's usually not many. It's basically number, string, object. And again, we can try them out just by looking at the node interpreter, right? Like a instance of, oops, a instance of string. Oops, I don't know what I'm doing wrong there. What am I doing wrong? Have I screwed up anywhere? Anyway, let's just run this code at least. Let's get out of that for a second. If I run this code here, which is 3.3 many string runtime, you'll see that this code, why doesn't it like this? This is so strange. Did I screw up the code? I probably just have an error in my code. What was the example they gave here? Instance of car. What am I doing wrong? Right hand side is not an object. Oh. It's meant to be that? I feel like someone corrected me on this. Okay, it was that. Sorry. I think I must have gotten that mixed up with something. I swear we got that fixed up. So either I didn't fix it and thought I should have, or I broke it by fixing it again. So you'll see if we do something here like what's the instance, is A an instance of a string? It's like false. It's not a string, which is very confusing. Don't know why that is. But, we could see, is 4 an instance of a string? Is 4 an instance of a number? False. I don't know why any of those are false. That's okay. This was all winged. But when we look at this program, it succeeds and it shouldn't. Why shouldn't it? Instance of car. Well, how do we find out the type of something in JavaScript? Okay, type of JavaScript. Let's see what exists here. Right, JavaScript type of. So we'll probably find this command. Where is it? Type of. So we can actually go and get something, right? And we can see if it works. This is probably where I screwed up. So if I go back to node here and I say type of A, you'll see that it's a string here. Okay, now I've clearly made a mistake here in the lectures today, and we'll catch up on that. And if I do a whole bunch of different things, you'll see that these are all objects, or if I say, A, B, C, like this, it's another object. So this is interesting, right? You think that's an array. It's not an array, it's an object, because everything in JavaScript is an object. What other types do we have? What about 4.5? That's also a number. So you can kind of start to see, what's the type of null? I think type of null is null. Oh, type of null is an object, right? There you go. Very confusing and very broad. I feel like there are a few ways to do this, because as you can see here, I feel like instance of is probably tied to objects more so than primitives. This isn't actually part of the lecture, to be clear. This is actually meant to be pretext to the lecture, so not a lot of time was spent here. But let's just try type of repeat equals number. Let's see if this is let's see if this works for us. So let's try type of 5 equals number. True. Okay, good. So that's one way to do it in JavaScript. I think instance of is probably more relevant for doing things with object-oriented programming and stuff. So you can probably just ignore it. None of this matters because you're not actually ever going to do what I'm showing you, okay? That's why the example's so crap. So it's we check. Let me fix this up. We check if the type of repeat is a number. That's also why this was a thing before like that. So it's yep, is the type of repeat a number? Is the type of string a string? And if it's not, it will crash like this. Why didn't that crash? We passed that in. Type of repeat should have been, oh, if it's not a number. Sorry, got the conditions wrong. Yep, if it's not a number, it should crash. So you can see here what happens is when we call this function, we pass in hello the string into repeat. It checks what's the type of repeat. That this function here returns a string. That string is going to be string, funnily enough, right? Like if you type in, type of hello, it's a string. And when we compare that to number, because it's not a number, we print an error to the console. Console.error is the same as console.log. It just sends it to standard error instead of standard out. And then we return undefined because the function, is nothing happened. And that's why you can see this program. It prints the error repeat argument is not a number, and then it returns undefined because we tried to print the result out. So this is how we're kind of checking. This is how we are improving the safety of our program because we're preventing accidental misuse here, right? So thanks for your patience amidst this check here, but it's the exact same principle. The thing is, though, that what we're doing here is this is dynamic verification. This is us verifying it at runtime. The program has to run for us to get it working. So even though we're kind of checking types, it's not what you'd call static verification. This is what we would call dynamic type verification. What we're interested in this lecture, hence the name, is static verification before it runs. So then this is where we get into the topic of type safety. We talked again a bit about this in lecture 2.3. Type safety is basically preventing any mismatch between the intended type of a variable and the actual used type. That was the problem here. There was an intended type for repeat, which was a number. Someone tried to use it with a string. That's very naughty. C's type safe, as you have to declare all the types at the start of the program, but JavaScript by itself is not type safe. Everything in JavaScript is typed, as you can see, because things have a type of. You know, people will, including me, will say things like JavaScript doesn't have types, but JavaScript does have types. The type of hello is a string. It's just that JavaScript determines it for you. Therefore, it's not type safe inherently because JavaScript, you aren't using types as a constraint to control things. So types aren't actually known till the program is executed, and they can be dynamically changed whilst the program is executing. So the solution we saw was about checking type safety dynamically, right? Catching it at runtime. We'd like to do that statically. This line here is out of date because I swapped these lectures just before the course was starting. Forgot about that. Thank you. So don't worry about that. That's actually the one we're going to talk about next. I just swapped those two around. So how do we check for these types statically in JavaScript? And the answer is something that I know a whole bunch of people here have heard of, which is Typescript. Typescript is a language built on top of JavaScript. That's already going to confuse some people. Its job is to check the types in your program and output JavaScript. That JavaScript is then run with Node. So to understand what Typescript is, you kind of have to think of it like, you know, like imagine if you draw a smiley face, like, right? The reason it's a bit confusing is because so many of you just understand languages like C and JavaScript, right? It's two very different languages, right? Like C's over here, right? JavaScript's over here. But what Typescript is someone who said, you know what, let's take JavaScript, but let's actually make like a bigger version of it that has more stuff, and we'll call it Typescript. And it's like JavaScript, but it has types in it. And that's kind of what it is in a nutshell. And its job is, ironically enough, to output JavaScript, which is very strange, right? Like we learn when it comes to C that C's job is to write code. The GCC compiles and outputs to machine code, stuff computers read. But Typescript is more like a language that outputs JavaScript. And this is actually some TypeScript code here. What do you notice about this code? Notice a couple things. Firstly, it looks really similar to JavaScript. Pretty much the same, except for like one thing, which are these colon number here. Besides that, it's all just normal JavaScript. And you can obviously start to figure out this is called Typescript. We have a lecture on static type verification, and these are types. So Typescript is JavaScript where you specify types on things, kind of like C. But the most important question to start with is how do we run this code? We've got this code here. How do I run it? The code is sitting right here, right? How do I run it? I can't say node source / 3.3 mycode.ts. JavaScript looks at it, like the node interpreter, the compiler looks at it and goes like, I know my head's in the way. It goes like, hey, what in the world is this colon? I have no idea what that is. I have absolutely no idea what you want me to do with that colon. You know, it's very confusing. So we need a way to actually run it. And that's because what we tried to run it with was the JavaScript interpreter. But to run it with TypeScript, we actually need to install a TypeScript interpreter. So if you have a project, like a lab or any other kind of NPM thing, all you need to do is go to your terminal and you just need to install both TypeScript and TS Node, which are both development dependencies. That's why the save dev is there. And it'll go and install those into your NPM project. There's already one I have here. I've talked about NPM a lot, so we'll just kind of gloss over that. So you go and install those two things, and then what you're able to do is you're able to actually run, that's another small typo. That's okay. Thanks for your patience. We're actually able to run our code by running node modules /bin/ts node. This C here is a typo. Sorry. That's just a little silly typo from me. And we can actually run it with ts node. So normally you'd say something like, node. Oh my god. Felt like, when you drink like Coke or something, and anyway, it doesn't matter. Don't worry about me. So it's like the node interpreter for JavaScript can't run it, but the TypeScript node interpreter can run it. The only problem is the TypeScript node interpreter isn't installed on the computer. Like, do you remember when you installed Node on your computer? Or when you might if you did it locally, but if you're using the CSE machines, it's a program like Chrome and what does anyone else use these days? Microsoft Paint and Firefox and Microsoft Edge, right? But it's not a program you install from the internet. It's actually an npm module, just like Jest. So we have to install it just like Jest, and therefore to run it, we have to go into node modules.bin/ts node, and then run our code like this. I hope that works. Yay, it worked. So that's how we run it. We run it with /node modules.bin ts nodes. This is like a different node interpreter. So we're kind of looking at like a different compiler here, basically. And all that compiler does is exactly the same as what JavaScript does, except with the bonus feature of being able to interpret types on the language. Now you might be thinking, God, that's annoying and stupid. Why don't they just put types straight into JavaScript? What a great question. They're trying to do that right now. It's a big thing I think Microsoft has been. I don't remember the specific news, but like TypeScript native in Node. I think it's a big thing that's been going on. Where they have been, they basically, like, the world have been coming together to figure out how to make it happen. This is not the page. I don't know where it is. I'm sure there's someone can link it somewhere. But there was a big thing. They were all trying to, like, get it into the language so that you can actually run Node on TypeScript. You can run Node with TypeScript. On TypeScript, whatever the expression is. So there's my simple program here. Now you notice the syntax highlighting isn't working for me because, I forgot I don't have the thing installed. I should probably go and install it. And I know a bunch of people will just laugh at me for not using VS Code, but you can laugh at me. I'll go and install the thing later. If I try and use the JavaScript, let me sort that out quickly. So there's our install package. I'll do this really quickly. See if we can do it quickly. TypeScript. Hopefully this solves my syntax problem. Syntax? TypeScript? I can't see it. Is it too far down? TypeScript. Yay! There it is. So I've got this function called, sum, and it does the exact same thing, and it's perfectly fine, and that's how we ran TypeScript. Now, just like we did with Jest, it's actually 100% possible to, instead of having to type out this whole big command, we can actually just go and add it to our package.json like has happened here. Right? Remember how we did this thing with Jest, so that instead of having to type in the .node modules.bin.ts node, I could just type in Jest. If we do the same thing here by putting ts node there and then ts node here, I can actually just write ts node. I actually have to say npm run ts node source 3.3 mycode.ts. Right, so it's just like Jest. I can have these little shortcut commands that'll go and run it for me. So I'm just looking at the chat. Neil asked a great question. So for our PCs, do we have to install TypeScript? No. I might not have been very clear on this before. Let me try again. So all you need to do to run the course is install, we installed this on the CSE machine. It's like Git and Node, basically. Node comes with npm, and npm is then used to install lots of other stuff. So like you installed Jest to do testing. TypeScript's another thing you install. So it's like TypeScript is installed through npm. So like I guess technically you're installing it, but it's no different than when you install Jest or something else. So there's nothing you need to do besides follow the instructions. Nick says, with the amount of additions to make JavaScript work, when does it become sensible to write a new language? There's a great quote I love, which I might have mentioned to you all before, which is that there are two types of programming languages, those that people use and those that people complain about and those that people don't use. Most languages have problems in it. Pretty much every language I've ever used has a whole bunch of people who love it and a whole bunch of people who hate it. I imagine that starting a new language, there's been attempts, right? Like you can go Google this. There's been attempts to write different kinds of languages. Like there was CoffeeScript at one point, and then there was another type of thing. And TypeScript was another spin-off that just worked. Sometimes people do these things that just work a bit better. It just happens. Neil says, when we run npm install in our tutorials, does that install all the libraries we need? So we love you a lot. So what happens is in this course, we either put everything you need in the package.json or in the lab/project instructions, we tell you exactly what to do. So you don't actually need to figure it out. We either do it for you or we tell you exactly the commands to copy and paste. We're not trying to give you a headache. We're not trying to take your time away from, problem solving, right? So don't worry. We're very, very helpful with that. Daniel, who's our original C lover from week 1, all languages slowly reverting back to C. I want to touch on this really, really quickly. So there was a massive boom, I think, of loosely typed languages like Python and Perl and PHP and JavaScript, maybe 15, 20 years ago, something like that. What happened slowly was that a lot of these languages, they stopped being used for kind of dinky little websites that were buggy, and they started being used by serious companies trying to do serious things. And what happened was that the kind of novelty of having this really simple to build, this simple to use tool, which didn't have types. I went and talked to a whole bunch of people in the labs, right? Last week. I went and visited a whole bunch of Tuesday labs and Thursday labs, and hi everyone to people I saw in those labs. People all were like, JavaScript's so much easier than C. It's so easy. That comes at a cost, and eventually people started to realize that the lack of static verification, that lack of type safety, was costing things at scale. So for instance, if I was to go build a big website, a big project, that I was going to work on for a couple of years with a whole team of 5 or 6 people, I'd probably use TypeScript because it's more robust and it will save me pain in the long run. If I'm making something for a CSE SOC projects competition, a hackathon, I would absolutely not bother because I don't think the overhead of setting it up and running into all these small problems is worth it, right? It's the same with C, right? You wouldn't go and do something in C that takes longer. So there's no right or wrong. There's just kind of different applications. But let's get back to it. So that's how we ran it. We ran that with TS Node. One thing that's really important, though, is that when I did this here, this TS Node program goes and runs the code. It actually goes and, what would you say? It goes and type checks your code, and if it can't pass the type check, it fails you. It basically kind of compiles your code. Have a look at this. If I replace 1 here with A, watch what happens. When I run it, it will fail me. And this isn't it running the code. This is it actually failing and saying, hey, argument of type string here is not assignable to parameter of type number. So TypeScript has gone and figured that out for me. And that's very, very useful here. And if there are no type errors, it will just run it normally for me. Now, in your project, and in general, sometimes you want to be able to use TypeScript to check your code, but you don't actually want to run it. You don't need to run your code. It runs. You just need to kind of sanity check it, sanity compile it. And there's a second command that gets given to you with TypeScript, which is called TSC. TSC, I think, stands for TypeScript check. So there are 2 commands that we've been talking about right today, which has been TS Node and TSC. And TSC type checks and TS node type checks plus runs. Right, so it does both of those things for us. So sometimes if you only want to type check your code, you can actually go and run this particular command here if you want to, which again, you don't need to worry about the specifics. I run that command, and what this will do, oops, let me get rid of that dot, is this will actually just go and make sure the types work, but it won't run anything. You'll notice that when I run this program, it doesn't actually, oh, there you go, my bad. I need the source. I need the source. Right, I've got my code there. I go and run that code. Oh, TypeScript compiler. Thank you. Sorry. Thank you. Right, TSC, TypeScript compiler, not TypeScript checker. That doesn't make any sense. So it's like, here, you notice it didn't actually run anything at all. It just checked, and you can tell it works if I replace this with a, you know, a number to a string. It won't run the code, but it will still check it. So I'll still get that error we saw up above where it's like something's gone wrong. So again, TS node is a program that just runs the TypeScript compiler, TSC, and then it actually runs your code at the exact same time. The way TypeScript actually works, and this is kind of important, is that when you go and run TSC on your code, right, it actually goes and outputs a JavaScript version of it quietly for you. Sometimes they'll make it visible. So you notice here on the left-hand side, have a look at this. Let me just run this properly. So when I run this with the correct input, the correct source code, have a look at what TSC outputs for me. It actually outputs this, sorry, just wait, give it a sec. It outputs this JavaScript file. You notice how it's nearly the same? Right? It's just that the types are gone. So you have to kind of picture TypeScript as something that goes through and looks at your code. Like, remember how you had this thing before? It goes through and looks at your code, which is just normal JavaScript with some types. And it says, yep, all the types match out, big tick. And then all it does is outputs JavaScript. And then that JavaScript gets run. So I could then go and actually run that JavaScript just normally. The problem is that this gets really annoying for people to have to kind of have like this like step where you kind of compile the TypeScript into JavaScript and then run the JavaScript. It's all very complicated. So that's why the TS node command exists, because some people were just like, you know, it's going to be a lot easier if someone just runs TS node and it just runs TypeScript as if it runs like JavaScript, right? Like all super, super easy. So as you can see there, instead of node, it's TS node. And it's the same code except there are types involved, right? Very, very fun. So question from Brendan. Would the syntax errors and type errors that are displayed in your IDE fall under the static testing category? Yes, and that's actually a huge reason why static verification is popular, because it allows you to kind of find errors in your code before your code runs. You can see there's an error here that is kind of wrong. That's the wrong error. But you will see that if I go and put something here like your IDE, VS Code and stuff will actually pick up on it. And it will actually tell you. Here it's saying that, hey, I see a function that takes in 2 numbers, but you gave it a string instead of one of those numbers. Right? Not good. Just like we see this a lot with things in the course, don't stress about what an IDE tells you. We'll see this come up on the forum 100 times. IDEs will sometimes, depending on your configuration and some other weird things going on, they will sometimes complain about something that's not a problem. If you want to know if your code is type safe, as in if the types are okay, don't look at the IDE, actually go and run npm run tsc on your code. Oops. Right, go and run that on your code. This is how you check if your code is like type safe without running it. Right, so if I run that command and then it comes back and it says like no error, then it's like great, my code is type safe. Very, very simple. As I mentioned before, we've kind of touched on this, but just like we did with TS node, we can add TSC to the scripts so that we don't have to write out that whole node modules bin command. We can actually just write it out like this. There's a few other configuration things that we add that you don't need to worry about. Again, everything we're talking about at the moment is all just background and context. Most of this we handle for you. Let's get back into our example though and try and use TypeScript to fix our broken code. So we saw before that we had this code here that was broken and we didn't know. Then we tried to fix it up by adding a whole bunch of runtime errors. But now we'd like to go in and fix it up with TypeScript. So what I've gone in and done is I've gone and added that repeat should be a number and string should be a string. So now what I can do is I can say npm run tsnode source/3.3 my code broken, like this, pretty normal. And then it will fail to compile. It'll, say argument of type string is not assignable to parameter of type number. So it did just fail here. And it's like, oh, okay, well I have to go and change this. I had these the wrong way around. So what this essentially means is that now you're in a position where your code is not going to break for type errors because, you have this great way of checking. It's really good. Really, really handy. It helps reduce a bunch of errors. It's one of the fastest way you'll ever clean up bugs in your life is static type checking. It's really, really powerful. So that's the gist of it. That's what we're doing. As we've seen before, if you run tsc or tsnode, tsnode again will compile and run your code. tsc will just compile it. For the sake of this course, again, it's really, really simple. When you want to run your code, you use npm run tsnode. When you would like to only type check your code, you use npm run tsc, TypeScript compiler. So tsc's TypeScript compiler, tsnode is the TypeScript compiler, and it runs it straight after. Daniel says, what happens if your function is in a multi-file project and is being called by other users? Then they have to write TypeScript code too. I'm not 100% sure what your question means, but an entire project either needs to be TypeScript or, generally speaking, everything needs to be TypeScript for it to work. But let's actually have a look at how to, oops, where the hell am I? Let's have a look at actually how to use TypeScript properly. Types, like now we're just writing TypeScript for a while. So how to TypeScript. Types are added to programs typically by putting the type name after the colon. So we write function sum a colon number, b colon number, return a plus b, right? This is what we just saw before. It works perfectly fine. We can put types here, but if you've been paying attention, you've probably got a question already, which is what types exist. Like, sure, Hayden, we've talked about number and string, but there must be other types out there, and there is. We're going to talk about those in a second, right? We're going to go through a few, like examples of typing. But before we get to that, just looking at a bit of the syntax here, TypeScript doesn't require you to put types on everything. And this is one area that differs from C and a few other languages. TypeScript is really good at doing what we call type inferencing or type inferences. I don't know what the exact word is. So it's like type inferences are where TypeScript will automatically figure out what type it is that you are referring to. So what I mean by that is if you go and write a function here like hello, and we can see this just by modifying this file, right? I'll just go and change this file. This function called hello. If I don't put this here, you'll notice that if I try and TypeScript compile it, right? So I'll go and try and TypeScript compile this 3.3 my code broken. If I go to TypeScript compile that, it will complain. It'll say parameter name implicitly has an any type. We'll talk about what any types are soon, but what this really here is saying is that the name parameter here could be anything, quite literally. You haven't really specified what it should or shouldn't be, and that's not very helpful. So I need to go in and specify that. So I need to say, okay, name is a string. Now, where things differ is that if I instead define, maybe let's make a program now called const name equals Hayden. I don't need to. I can go and say, you know, name is a string here, like that, and I can console log it. Right, this program works. I don't know what you're complaining about. Yeah, it's fine. I hope this doesn't get angry at me. It's getting angry at me. Something you'll see appear in a lot of lecture slides, and I mean a lot of lecture slides from here until the end of the course, right? Is you'll see this little export funny brackets appear at the end. There's a really long-winded reason that these need to be in the lecture slides. They never need to be in any code you write. The reason they need to be in lecture slides is when you write code that... the really simple example is that if you write code that kind of is stupid code, you run into problems very quickly about the way TypeScript expects your packages to work. This will never happen in your labs in your project, but it happens a lot in the lecture slides. So if I ever have a line at the bottom here, you'll see this at the bottom of tons of examples. It'll usually just say, where is it? Or did I get rid of it? I must have gotten rid of it. Anyway. Yeah, you can just ignore this line. It's an annoying relic of JavaScript, of TypeScript that just doesn't affect you at all. So you'll see this actually works now, but if I actually get rid of this string part here, so it's just const name equals Hayden, you'll also notice the TypeScript compiles that perfectly fine. It doesn't need types at all. And in fact, what's funny is that this code is so simple that I could actually just run it with Node, except it doesn't like that export. But that Node program kind of works, right? So the point here is that don't mistake TypeScript for everything needs to have a programmer declared type. What TypeScript is for everything that TypeScript can't infer the type of, a programmer needs to define it. And TypeScript knows this is a string. You've literally said that name is equal to something that is a string. Whereas here, TypeScript's like, what is a name? If you don't tell me what it is, it has no idea what to do with it. So it actually isn't as hard as it sounds, because TypeScript will figure things out for you. So let's do some examples, right? The most three basic types in TypeScript are all really, really simple primitives. And those three primitives are string, number, and boolean. They cover a lot of basic types. And most other types are just made up of those things. So it's not quite as strict as C, where you can get into things like, you know, ints of certain sizes and floats and stuff, you know, off the bat. But you do have strings, numbers, and booleans. Now, when you define functions in JavaScript, functions will typically require that all of your parameters are explicitly typed. We've seen this just in the other examples that we've looked at here. However, whilst you can also type the return values, TypeScript will usually infer return values. So if I do run TypeScript check on 3.3 example functions, this will this will type check it fine, type compile it fine. But if I actually get rid of this part here, it will also work, because this part here is actually telling me what the function should return. So this is saying a function called hello that has a parameter name, that parameter's type is string, and the function hello's return type is string as well. So I can get rid of that, but TypeScript will be able to figure it out, and it nearly always can figure it out. Because it will look at what you're returning. Because usually what you're returning has an explicit type. Because think about it, it's like what you're returning is either like a variable defined in the function that already has a type, or it's a parameter that you've had to type. So it usually just works fine. The only times I really see this happen often are when you want to just enforce things more, like prevent other programmers from one day accidentally, you know, changing this to another type, but I don't think it's a big deal. So functions parameters are a must. Return values are an optional. You can get creative with types. You can use the or like the union symbol here, to say that something can be something or something else. So for example, if I have a function here, what was that function called? Unions. If I have a function here that is called printf ready, and it takes in a value, and if that value is equal to true, or that value is not equal to 0, it will console log ready. But if I want that function to be able to take in either booleans or numbers, when I give it the parameter here, instead of saying, boolean, like how do you figure out what that is? You can just use or. So what this literally says here is that ready can be a boolean or a number, but it can't be anything else. So for instance, if I try and call it with a string, like 0, Typescript will immediately pick up on that and notice it's like argument of type 0, string here, is not assignable to a parameter of type number or boolean. But if I was to make this a number or a boolean or a string, it would suddenly work now. So you can just use those unions in cases where something could be one of multiple types. That's not super common, but it is somewhat useful sometimes. When it comes to lists in JavaScript, in TypeScript, sorry, there's a couple of ways you can do this, though one really easy way to do it is to use the lists or arrays, same kind of thing, is that you can use this array syntax. So it's like, okay, if I want to create a list of 10 items, right? And I'm going to give you an item, and I want you to create a list with 10 of them in it. Basically, I want you to clone this item 10 times and return me a new list. So I've got this function create 10 list, and I pass in an item, and that item is either a string or a number. They're the two types I'm happy with. And then I want to create an empty array. And you know what? Like you can actually notice this pretty quickly if you try and write a program just in JavaScript, right? Because this is JavaScript here. This would compile with JavaScript Node. But when I try and, TypeScript compile, check it, or when I try and running it's the same. Maybe we'll try and run this one. Maybe I'll use TS Node instead. When I use TS Node, it will try and run TSC to compile it. Oh, so this one's working because I didn't use it? Is that the problem? Let's try it out. Oh, I'm running the wrong one. Thank you. Someone's probably already pointed that out in the chat. I haven't been looking. So here it'll complain because it'll be like, oh, okay. That surprised me. I wonder why that worked. See, it's quite smart. Like, this isn't a bad thing. Like, you should be thrilled. This is like code that works with JavaScript. And if TypeScript's running this fine, basically what it's saying is that TypeScript thinks that all the information is necessary there. Ah, okay. I understand what's going on. I've just remembered, right? So what... No, now I'm actually confused. Oh, it's the wrong file. Fuck. Gotta stop doing that. So, it's a little bit... I mean, it's not hard to explain. It's just the first time I've had to explain these things. The way we've set up the course, right, is so that when you run TS Node, it will check for types, right? Like, let's go back to the functions. Let's go back to the functions example for a second. So if I go back to functions, it will check for types, and it will not like if you use the wrong type. It will complain, right? However, the way we've set up the course is that when you use TSC, one thing it will do and one thing it will check is it will make sure that everything that should have a type is typed, like this. And this will not work. It will complain. It'll say, hey, name has no type. It is implied that it could be anything. And I don't like that it could be anything. I want to know exactly what it is. However, when you run TS Node won't complain about this. And the reason for this is because when you develop stuff with TypeScript, TypeScript takes time to type check stuff. It actually like takes the computer time and resources to do it. So for development purposes, sometimes when you're running code, to speed things up, you're happy with it checking less. You're happy with it checking fewer things. And what this means is that TS node will check most things, but it won't check everything for you. And that's just to make your life easier. We don't want to try and block you with all these problems. So this code still runs, like it runs totally fine. But when you use TSC, it does one extra check, which is no implicit any. And this one extra check will get annoyed at things like this. And we'll talk about how this integrates in pipelines and stuff later. But basically, the short story is that, remember how I said that like TS node is just TSC that then runs your code? TSC does actually one extra check that TS node doesn't. And that's why our code worked before. That's why when I was trying to run this one, this is why this one worked. Because this one does work, except that item is not defined, and therefore you know, it's TS node's relaxed with it, but TSC will complain. TSC will look at that and get mad. So TSC sees that, and it says, hey, that's not good. Item here and array here don't have a type, right? Parameter item implicitly has an any type, and it's like, oh, well, what can I pass into this function? Well, I can pass in a string or a number. Okay, so now I run it again. I run it with the type check again. TSC. And it's happy with this one. And I'm surprised this works, because I'm surprised it's not complaining that the array here is undefined. Because sometimes what I've seen, and this is probably just my slight lack of knowledge, is here I would normally think it's like, I don't know what's in this list. I don't know what this list is of, but maybe TypeScript's even smarter than I realize, and it can look at what you're putting into it and figure that out. I actually don't know. But if you were to try and explicitly define this, and we might see this in, say, a program. Actually, I'd be curious. We could try this out. Let's try this out together. Let's try and do this. Let's make a really simple program that just creates an array and then just like pushes 10 A's to it. See what it does. Maybe it'll just figure it out. It's really quite a smart type checker. Yeah, it just figures it out. Where things can get complicated, though, is when, and this is actually a really interesting insight into type checking. It's when the type checker doesn't know what this thing could be. And you might have seen this in your labs, for instance. There's a particular lab I'm thinking about. I might actually show you this after the break. Let me log in after the break. So let's take a break, and I'll keep continuing with this example. Then we just have a few more slides to go. Okay, we'll probably do another half an hour on this. Linting will be pretty quick to get through. So let's take like a 6-minute break till like 7:07, and then we'll just keep smashing through it. And I'll answer some questions as well. I'll answer some questions quickly before the break. This might be a dumb question. Daniel says this might be a dumb question, but is there production code running on TypeScript, or is it just a way for programmers to communicate clearly assumptions about function types, etc.? That is an extremely good question. TypeScript is for developers. No code in production. Well, let me rephrase myself. Generally speaking, code in production is not type checked when it runs because it's slow. It's slower to run. And if you check it locally, you know it runs in production. So TypeScript is for developers. It does not make your code you run safer, because if you've written it in TypeScript, it will kind of run JavaScript underneath. So it is for developers, and that's why and so when you say things like, you wouldn't say like, I have a server that runs TypeScript. Everything's JavaScript, right? You write JavaScript, your server runs JavaScript. TypeScript is just this kind of wrapper language that sits on top of JavaScript that you as a programmer use to make your JavaScript better, to make sure your JavaScript works, so that when your JavaScript runs on a server somewhere, it works. That's the gist of that. So let's go take a break. We'll start up again 708 and keep going. Okay, so let's keep moving. What I wanted to show you is that I went and stole something from one of the labs. So if you go to the new labs, like labs in week 3, you'll see that the labs have sometimes they do an import called prompt sync. And prompt sync is this really simple library where you can say prompt sync like this, and what it will do is it will suck something in from the terminal from our user, and we can kind of grab it. So I have to install it first, so I have to install prompt sync, the library, right? npm install prompt sync. I want it to be used in production, like it's not a dev tool, it's an actual thing that makes the program run, so I do the normal install. And now you'll see when I ts node my program, it should actually prompt me. It won't actually did I do it wrong? What did I do wrong? Should go read that lab. Prompt sync. Prompt. I probably didn't do this right. I probably have stolen this incorrectly. Let me try and do this. See if this works. Sorry, this was impromptu. This wasn't part of the plan. Oh my god, I shouldn't have decided to do this random tangent. Oh, whoopsie daisy. Someone might have already done this and figured it out. I thought I could just copy that as it was. Nope. That's okay. We can quickly Google it. Prompt sync. Bing will find me the answers, has said very few people. Yeah, it's given me a bunch of old style imports. Blah, blah, blah. This is a lesson in don't make things up as you go, because you will regret it, like I'm doing right now. There's prompt sync has a particular style of importing. It's all the same stuff. All right, that's okay. I tried. We know that from previous labs. Here, I'll give you an example that's a little closer to home. We know that you can open a file and you can decode that from JSON. We did this in lecture 4.1. Be really simple, right? What do? We can import fs from file system, and then we can go and open a file. We can say, const data equals file system.read file sync, and we can open up a file called data.json, and we can open up with the flag R for read, right? This is what we did last night. And then what I'll do is I'll call this one, I'll say it's JSON because we're going to open a JSON file, and then we will parse the data from JSON, and then we'll print out the data, right? And what I will do now is I will go and create a new file in this folder called data.json that will just be a dictionary that says number is 5, like that. Okay, really, really simple. Now I'll try and run my program again. Now you can see that Typescript is complaining. It's saying argument of type buffer is not assignable to type string. Now if you remember that lecture, you remember that we had some problem because read file sync actually returned a buffer. And this is an example. Typescript's quite pedantic. It's like, sorry, JSON parse expects a string, and now I had to convert it to a string. And now it's complaining that data.json doesn't exist, which is very strange. I think the reason for this is because I'm running this program in a different directory here. So I'm running it from like the env2 directory, but my code is in source/something. So therefore I need to do the same pathing. Opening files on operating systems is very strange. And there I get my number 5, right? So now what happens if I try and push that number, right? Data.number, like this, okay? So I'm opening that file to get the number, and then I'm pushing it to an array 10 times. Let's see what Typescript thinks of this. I can't imagine this working. Actually, TS node won't mind, but let's look at TSC. TSC is the one that doesn't like things being untyped. Yes, Kai's right. Kai was 3 steps ahead of me here, I think. Yeah. I don't know why, because I think a lot of our examples don't include imports. There's so many plus sides to using JavaScript in this course, honestly, but there's a few downsides, and some of those downsides includes having to do random configuration things, which are kind of a headache. And it still doesn't like me importing that, and I don't know why. Import file system, oh my god. So this is like, people always talk about TypeScript as if it's this amazing thing. You hear people talk about it like it's somehow solved, cured cancer or something. But what they don't like to talk to you about is how many random problems you can come into. And I'm not saying this is one of them, because this is just me being a little bit silly. But it's actually quite a headache sometimes. You kind of have to. I was wondering, Kai. I was thinking. I didn't think that was a problem, but I was wondering. Why doesn't it like it? I probably screwed up something to do with. Lord. This is particularly bad. So basically, but okay, let me take a step back. I'm just making this up. I'm going to get this wrong. I'm going to have to stop. When it comes to running your code with TypeScript, there's actually quite a lot of configuration that was necessary to get it working for you. And that took a lot of time from us and the tutors. And that's why we give you a whole bunch of files, right, to run. Like a bunch of configurations. So you don't have to go and figure out any of it, which is really important. And save you the headache of problems I'm having right now. I'm not sure why this isn't running. I can go and have a look at it later. Someone also might know in the chat. But essentially, my point here is that the example we had before, which was like this, right? Where we had this. When we were just pushing like the number 4 to this array, TypeScript was able to look at what we were doing and say, well, I can tell what the array is because you're pushing a 4 to it. So it's kind of clear to me what type exists in that array, right? TypeScript can infer that. With the above, if you imagine for a second that you are like TypeScript, how do you know what data's in that array? Right? What type is it? Is it a number? Is it a string? Is it a Boolean? Like, you don't know. And the reason you don't know is pretty much because it's not possible to know at compile time. Right? It's just not possible. Because the JSON file could be anything. So therefore, in cases like this, and this has been a very long 20-minute tangent, and I kind of regret it. Or maybe we can try it out. Kai's suggested something. It's funny, when we made this course, there was a bunch of different people who had different opinions about TypeScript, about whether we should do it or not. And I think that's still going to be. Yeah. Okay. Doesn't matter. I honestly would consider snipping that whole part of the lecture out. It's like. But here my point, the whole point of this, if we jump back 15 or so minutes, is that when you define arrays in TypeScript, you define them by wrapping the type inside this array with the side brackets. And when you do that, you're essentially telling it that, this ARR variable here is an array which consists of strings and numbers, strings or numbers. So I have a function here, if we go all the way back to the start, I have this function here called create10list. It takes in a string or a number, and then I have a variable here, array, which is an array of things that are strings or numbers. And remember, this means that the array could be full of strings and numbers, because it's the the mathematical OR, the union, and then push to it. So that's how we do arrays. Let me move on, because I'm wasting a lot of time. Another cool thing you can do in JavaScript is type aliasing. This is really, really helpful, particularly when you have an example like this one here, where you have something like string and number, and you feel like that's taking up a lot of code. So what you can actually do is you can actually say type list item, and you can actually define your own types as if they're variables, right? Like this. And then I can go and use that in place of that type and kind of clean up my code. It's just like learning to program again, right? Except instead of storing variables up in one spot, we're actually just storing types. So now I have a list item here that's able to abstract those out. Oops, yeah. It's a different code example. So this one should still work totally fine as well. So that's type aliasing, really, really simple. Then we get into type optionals. These ones are a little bit more interesting. Type optionals are really good when you want to say that something may or may not exist. So for instance, in this case here, if we're writing our own substring function, which is an interesting idea for a function. How do we take a string and how do we extract a smaller string from it that starts from this index and is this length? It's a really common function you'll see in many programming languages. So what we really like here is for Hayden to be able to pull from the 0th index, which is the start, and pull 1, 2, 3 characters. However, if we don't specify an end, it's not really length, it's like an it's more like an end index, sorry, not a length. If we don't specify it, we want the substring function to essentially take it from that index till the end. So this one here says index 2, which is from the y, and because we haven't given it an end property, we want it to just go all the way out to the end. So how do we like teach TypeScript How do we tell TypeScript what this means? And the answer is pretty simple. If you put a question mark before a colon, what it tells TypeScript is that whilst the end variable is a number, that end variable might also just simply not exist. And if that end variable doesn't exist, that's totally fine. So this program takes in 1 variable string, 2 variable number, 3rd variable is a number, but that number might not exist. Now, the benefit of this syntax is that it's actually the identical syntax to a union with undefined. So when you say question mark colon as a number, that's actually exactly the same as saying that or undefined. So it's not really something you like need to know. It just kind of cleans up your code a bit. Because I could very easily not have done this and just said, you know what, end is either going to be a number or it's going to be undefined. Both work fine like that. You know, this is just a shorthand way of doing it. Didn't like what I had here though. Didn't like that number undefined. Yeah, it's not exactly identical to it. I tried to simplify that too much, but it's kind of conceptually identical to it. This is really, really common and useful because often you'll have functions that have, like you've probably written functions already that sometimes have parameters or arguments that you use that just simply aren't actually used. So a lot of this has been pretty straightforward, right? Optionals, aliases, lists, unions. These are all fairly straightforward concepts. Objects is a little bit more interesting. One of the problems in JavaScript, or again, I guess I mean TypeScript, is that when you go and define an object like person here, JavaScript actually wants to know what the type of that object is. It sounds a little bit strange, but I'd say that TypeScript is not great at inferring object types sometimes. So if you have something like this, you actually might need to go and create a type for it. So don't be confused by the syntax here. We know the simple rules of TypeScript are that when I have a variable, I do a colon and then I put the type here. All I'm doing here is putting that there. It's just that like to clean up my code a little bit, I'm doing what I learned with aliasing and I'm defining it up the top further out. And what I'm saying here is that the type person is an object that has a name key, an age key, a name key that's a string, an age key that's a number, but that age key might not exist, and a height key that's a number, but that height key might not exist. And therefore what happens is if I create a new person, and that person has a key that's, name Hayden, TypeScript knows that this is okay, and it knows that if I come down and I say, the age is 8, that's okay too. But if I then say, the width is 5, TypeScript will get mad at that because it's like, hey, that's not right. I am not expecting that. And again, if I try and run this one, I'll get in trouble, and it'll say here quite literally, right? The type, this, here, which is what I've tried to define. This is basically describing this type here, is not assignable to type person. Object literal may only specify known properties and width does not exist in type person. It's literally saying, hey, width is not a property of a person, right? So you can't do it. So if I get rid of that now and I try and run the program, it'll be happy enough, right? You will see though that it still lets this happen in this particular case, I believe. And this is because age is a type of a person. Oh, age is here. One sec. I was wondering about that. Let's try this. Let's see what happens if I try and get the age property of a person. See what TypeScript does. Okay, it didn't mind that. What if I try and say if person.age is equal to or is greater than 0? Console, or greater than 18. They are an adult. Like this. Let's try this, see if this works. Sorry, it's a bit slow. I mean, it's slow because it's having to do the actual type check. You know, and again, TypeScript will be pretty smart to figure a lot of these things out for you, but sometimes it also, again, just won't. And you'll just have to read the errors in certain cases. I'm kind of surprised it was okay with this one, because age should theoretically be undefined or potentially undefined. I don't know why that's come up as an any. I'm kind of worried I'm making a mistake here somewhere that's causing me grief, but that's okay. Figure that out later. I'm definitely probably doing a little something silly, but that's okay. So objects, pretty much with objects, you just have to define the type somewhere explicitly, and to do that, you just go and define it above. And then the last couple of things, last few slides, which is literals. One thing we haven't talked about is the idea that types don't actually have to be like string or number or boolean or something. They can actually be real things, or what we call literals, in terms of if you have a function, right, such as here, example literals, and that takes in this like create channel function with like, which like hint you'll see in your project a bit, and that function takes in a channel name but also the visibility of a channel. Sometimes, for instance, rather than passing in like a true or a false here, like, because you could have a function that takes in like is visible, you know, and that could be a true or a false to determine it, or like is public. And that's all well and good, but sometimes it might be better to have just a visibility variable and have that be the public string or a private string. But if you just say string here, the problem with just saying string is that like, whilst you might want someone to only pass in public or private, the literal string, it doesn't stop them passing in something else. So, you know, if I come down here and I say, you know, create channel, and I pass in like hello, this is annoying because it shouldn't work. I don't want it to work because I want it, oh my god. What's that big error for? Literals. Right, I don't want this to work. Expected two arguments got oops, sorry. Channel name. So this will work, but I don't want it to work. However, if I change the type from visibility to visibility here, this will now fail because hello is not one of these literal strings. It'll say hello is not assignable to type visibility. Visibility, it doesn't say anything more than that, but visibility has to be private or public. So now I can actually teach my, like, I gotta stop saying teaching. It's such a weird word. I can tell my program to only work if I give it one of those two particular strings, which is very powerful. And then the last thing we have here is the any keyword. Any is a type that is kind of, it's the type that makes TypeScript pointless in terms of, if you go and type all of your types in your program as any, it's just JavaScript. Like, if all your types could be anything, then TypeScript has nothing to check. And if TypeScript has nothing to check, what's the point of you using it? So, where it's great, though, is to stub things when you don't know what something should be. So if you're, say, defining a new function and you want to come back after and have a think about what that type should be, or go figure it out later, or you're just not sure how to do it, you can put any there and then come back and fix it up later. So in a case like this, where we have this any code, this code will run totally normal. It just makes TypeScript pointless. There's no point having TypeScript here. So it's a good starting point. It's a good stubbing point. I don't want to put pressure on people not to use it. But the other reason it's really useful, and this is the reason that TSC is stricter, it's the reason that TS node is actually nicer to you than TSC is so that when you eventually convert your projects to TypeScript in iteration 2, not iteration 1, what happens, or what can happen, is that TSC will complain about your code, right? You see here, TSC won't like this. TSC will be like, there is a, it's definitely because of this stupid thing. I think I know what the problem is now. Oh, do I up the top? Damn it. Okay, thank you, Kai. I had this random keyword in my code here, TS no check. When this is up the top, TypeScript ignores it. I forgot about that I put that there. So you see that TSC will complain about this code. It'll say that name is implied any. And it'll find a few other issues, right? Like substring has an implied, what is it? Lacks a return type. So it's like substring has a return type that's like any here. The reason we do this is so that when you go and convert your code to TypeScript, TSC will complain and TSC will fail you. But when you run TS node, because TS node doesn't care about the types as much, your code still runs. So the reason we set it up like this was so that TS node will still run your code normally. It'll run your TypeScript, but it won't check it. Because the last thing we wanted when we were designing the course was to kind of help you shift to a slightly different language that's nearly the same, but to suddenly have all your code not work and not run. So that's why TS node's more gentle on you. But you can still put those any's there in the meantime. That's perfectly fine. All of the information about TypeScript can be found on this website. Like, there's so much here. We just kind of took snippets from it. So a couple of things I just want to stress before we keep moving is it's actually a relatively simple thing. Like, TypeScript itself is just JavaScript with some type annotations. It's not a big, scary thing. Number two is that the configuration of TypeScript is the hard part. And you've seen this firsthand tonight in the lecture with me fumbling around, getting confused by a few things. That's mainly because it's the first time we've done it, so I'm encountering some problems I'm not used to. But also it's because every TypeScript project is configured differently. There's actually a file here that we're never going to ask you to worry about that has some configuration stuff in it. And this is going to be different in this project to another project to one you do on your internship. So this actually tells TypeScript what it can and can't do and what it should and shouldn't do. So sometimes if you go and learn TypeScript in this course and you go and work with it somewhere, what TypeScript is happy with you doing or not happy with you doing could be completely different. Or like, not completely different, but like, reasonably different. So there's some downsides to it. The downsides are that there's a bit more overhead and configuration. The plus sides are that once you get settled, it will make your projects a lot better. And again, thankfully, we do all the configuration for you. So there's no configuration for you to do. So don't be kind of fooled by, again, some of my fumbling today. We spend more time on your project than my lecture slides. So there's a few little tricky things there. Okay, so type safety, a summary of languages and their type safety. There are languages with non-optional built-in static type checking, C, Java, Haskell. right? So as in types are just built into the language. There are languages with optional but still built-in static type checking, like Typescript and Objective-C. And then there are languages with optional external type checkers like Python or Ruby. Yeah, basically what this says is that Typescript can ignore types if you tell it to. Like Typescript is something that can compile with types, but it can ignore them if you tell it to. Whereas C can't just ignore types. Typescript can run without types. It just doesn't want to. C just literally can't. So these are kind of the different categories that languages are in, really. The last kind of thing before we get to the end is migrating to TypeScript. Now, all this stuff here, you don't have to read. In fact, I would encourage you not to read it. This is just here for completeness so that you know what we do to your projects to make it run. I know it feels like we've slapped a couple of things on you in the last couple of weeks, where like last week with NPM, we started being like, go and install this and all that kind of stuff. But quite honestly, there are only 2 times in the course that we go and install a bunch of crap in your labs and project. And that's week 2 and week 3 and week 4. That's it. Nothing changes. So don't feel like this is like a mountain of things piling up. Again, we go and do all of this for you, pretty straightforward. One cool thing about TypeScript, as we've seen last night, do you remember how last night we had, for those who've seen the lecture last night, we had our own little file that we made inside of 20T2, which is the CI test program. So if you haven't seen lecture 3.2, this won't make a lot of sense. But last night we went and we made a CI test repo here. Now let's say I want to get this working with TypeScript. So I go inside my source folder and I remind myself what files I have here. Okay, which is like hello.js or whatever. All I would have to do to get this working with TypeScript is I'd normally have to go and like do a few configuration-y things that I've done here. And then I can just add npm run tsc to the pipeline. So like literally that will now run in the pipeline for me and check my code, which is very, very useful. So this is just something to consider in your later labs and your later iterations, is that your pipelines don't just have to be for testing. They can also be for type checking. So you can actually have your pipelines type check your code and test your code at the same time, which is really, really, really useful. I've said this before, don't stress. I know there's a few things here that might stress you out, but just guarantee you that when you sit down with it, it's all very manageable. So let's please take a moment to share some feedback here. Appreciate your patience. Again, this is the first new lecture of the course and a fairly, I don't want to call it a big topic because I don't actually think it changes a lot for you, but it's certainly a nuanced topic. Ethan asked a question. I'm going to try and answer this once, and hopefully you can all answer each other when it comes up again. Are we encouraged to use TypeScript in the project? You are not allowed to use TypeScript in iteration 1. Iteration 1 is week 3 and 4, this week and next week. When you start iteration 2 in week 5, you will be using TypeScript for the rest of the course, right? All you need for iteration 1 in terms of lectures, all you need, nothing more, is you just need the lectures from up until here. And in fact, you kind of don't even need you don't really need week 3 that much anyway, but it's kind of the same. The main things that iteration 1 is about are these 3 lectures. These are the 3 that will feel the most relevant to you. Yeah, that's really the crux of it. But yeah, this will all be totally fine. The good thing about TypeScript too is that we're going to keep using it in the course for the rest of the course. So it's not like it's like a new topic. It's like Git. We've mentioned it, and if you all remember, like think about this. We learned Git in week 1. A bunch of you were stressed about it. You did a couple labs, and you were like, oh, actually, this is not too bad. Now I got my head around it. TypeScript will be the same thing. It seems like a big thing, and then you just play around with it, and you're like, this is very, very manageable. So let's move on, because we got 20 minutes left. Let's wrap this up. So that's it on TypeScript.